to geometry. We are going through the Glencoe book and we are on chapter 1, section 3. This is the distance and midpoint formulas. So first off, we're going to start with some definitions. So our first definition is distance. Distance is the length of the segment between 2 points. The length of the segment between 2 points. Pretty understandable definition, right? Okay, midpoint is a point on the segment exactly halfway between the endpoints of the segment. So the point on the segment exactly halfway between the endpoints of the segment. Again, another pretty understandable one. You guys have all dealt with this. Now, a segment bisector is a segment, line, or plane that intersects a segment or its midpoint. A segment line or plane that intersects a segment at its midpoint. Remember, we just defined midpoint. Okay. So, first off, now we need to go to some distance formulas. So, we have quite a few formulas. We have a distance formula. The distance formula on a number line is the distance between 2 points is the absolute value of the difference between the coordinates. So let's draw this out. So we have a dot here. We have a segment right there. Yay, segments. Okay, segment. We have point P and we have point Q. P is also x1. Q we can see as x2. Okay, if P has a coordinate x, like we said, and Q has a coordinate x2, PQ, that's the whole thing, PQ equals the absolute value of x2 minus x1. It's an absolute value sign, okay? Or PQ equals the absolute value of x1 minus x2. Either way you do it, it doesn't matter. Since it's an absolute value, you'd either get a negative inside the absolute value, which would change it to a positive, or you get a positive and it would stay as a positive with the absolute value sign. This is pretty common if you think about this on a number line. I'm sure all of you guys can picture it. Now we're going to talk about the distance formula in a coordinate plane. So we're going to draw this out again. So we have our y-axis and we have our x-axis. Make sure we label x, y. Okay. We have a point P here. It goes up and up over here to Q. Okay, we have now P and Q. P has point, is at x1, y1. Q is at x2, y2, because it's our second point, right? So the formula for this is PQ, so that's the distance of the whole thing, equals the square root of x1, x2 minus x1 squared plus y2 minus y1 squared. Kind of reminds us of this one up here. See, we have x2 minus x1. So we have that up there. You just have to remember to square it and add the y's, which is the same one except for y, and square root it. Okay, now we are going to go on to the midpoint formulas. I'm going to write this under midpoint. You guys can keep writing it on a vertical sheet of paper. So we're going to do the midpoint formula on a number line. Okay, so how we do this, the formula for this, is if A and B have endpoints at x1 and x2 on a number line, then the midpoint of M has a coordinate x1 plus x2 divided by 2. I know, I threw a lot of that at you. So we are going to draw this out. So we have points A and B, similar to the one up there. A is x1, B is x2. Its midpoint, approximately there, which we're going to label M for now, which is going to stand for the midpoint, is x1 minus x2 plus x2, so we want the average. So we take the average, x1 plus x2 divided by 2, so we get the average. So this is a formula for the midpoint on a number line. Now we want the midpoint formula on in a coordinate plane. Just kind of like the distance formula, we did it on a number line, and now we are doing it in a coordinate plane. Okay, so if we're doing it in a coordinate plane, we have our coordinate plane over there. So let's draw this out again. Remember, we want labels. X, Y, okay? Now we have point, we're gonna put point P here, and this is x1, y1. And we have point Q down here, and this is x2, y2. And we have our midpoint, we're gonna put it about there, okay? And our midpoint is similar to over here. We want the averages, so we have to do the midpoint for x, so we get x1 plus x2 over 2, comma, y1 plus y2 over 2. Does that make sense? You guys can imagine these lines coming down, these lines coming down. This is x1, this is x2. To get to here, we use our midpoint formula over here on our number line. x1 plus x2 over 2. Same deal with the verticals. So we draw our dotted line. So we have y1, y2. How we get this is we do what we did over there. y1 plus y2 over 2. Okay? This all makes sense? Okay, I'm going to pause here, and then I'm going to do some examples in the next video. So thanks for watching.